now I'm doing a live stream of me building the Ant PCB mill, CNC PCB mill, and this is mostly for playback purposes, which is why the quality, well, I have only two cameras, which is a um the instructions to building this are located inside videos. So I'll be using this computer to look at the videos. And I am using all the parts as specified in the bill of materials, which I have printed over here. And essentially, I was able to source everything and print all the parts minus the O-rings, which I still do not have, but it's not the worst thing ever because building and testing are two different parts, and the O-rings really are for testing purposes. They're essentially arming the tool. So I even think they're one of the last steps in the videos, but I might be wrong on that one. I don't have the crimps for the new PCB adapter either, but I did find some crimps which could work, and I don't have the proper power switch. But again, I found a power switch which will most probably work. So the price for all this stuff, depending on how you get these items, I saw that it was probably around $500 Canadian, 500, 600, around that price point, which is not too bad considering that some like higher end PCB mills are at a price point of somewhere about closer to $2,000, $3,000, maybe even more than that. I think I saw something 5,000. Obviously, those are the very high precision stuff. There is obviously the very cheap stuff that I saw at a store where I bought a lot of these parts, a local store, which I was pretty lucky to have. Those are kind of rare for such specific purposes. And those PCB mills, those cheap ones, $200, $300, well, they're just the good old Cartesian, sort of cheap, pretty I don't want to say bad because it's not really bad, it's sufficient, but it's I guess not completely ideal setup. I do like the Core XY aspect of this, which gives a bit more precision. I do also like that it's very, very small. And any comments I have about any parts, I'll probably pass it when I get to that specific part. This assembly requires a bunch of mechanical assembly and a bunch of electrical assembly, which is why I have the sort of the mechanical tools here, which you really don't need that many of. Like, if you have a set of bits like this, you're pretty set for everything mechanical. It's fairly small parts. You do need a hammer at some point to hammer something in, which I will not be doing on this table since this is a flimsy plastic table. And then there's a bunch of electrical work that needs to be done, which for which you need to use a heat gun. I don't think you need a proper heat gun for anything in particular, but since this is a PCB maker, you're going to be using SMD components most probably on these PCBs, which I think it can do. Um, Getting one of these is never a loss. And then obviously I have a soldering iron. For anything soldering, you have to solder, I think, wires to this. I don't think you have to solder a lot of parts on PCBs, or I think there's a few connectors, but really not that many. And that's about it. So for electrical stuff, crimps, the usual. And these boxes here contain essentially every single part. and like I said, I'll do some comments on the parts as we get going. So this box contains all the printed parts, include and some stock material for when the CNC actually comes together, which of plates, like double-sided copper PCB plates, and they how do you call this again? Goddamn, solder mask ink paste thing, mabob, which is the fun part because I've actually have the all the stuff for the most recent development in the Ant PCB project, which is the good old solder mask curing using lasers. I have the laser, the exact one the team is suggesting to use, and we'll see how well that goes. And I will not be using the laser until I have made sure that either does not require or that I have the proper protection to use this laser. It's not a very powerful laser, but it is still a laser, and things these things can actually be quite the trouble if you don't use them properly. So this box, larger box, heavier box, contains all the other components, which there are so many of. I will not go through them. That would be ridiculous. I also have some extra parts here for a possible dust extractor, but I won't be doing that right now. It's probably going to be a side project. Parts are more difficult to get now because of the confinement thing. This is spring 2020. And if anyone wants to check the history books on that, there was a confinement that lasted from, I think it started mid March and is ongoing as of now, but probably will end in the next few months, if not in the next month, which is as of now May 2020. So we're going to have to get going with all this stuff if we can't really waste any time. I've already wasted enough time setting everything, despite us in the end just having 2 cameras. Oh boy. Well, I laid out everything nicely on top here, but this is kind of for naught. Let's get going here. So, first, the frame assembly is going to require hardware such as nuts, bolts, tons of stuff that I've gotten from overseas, and the maker beam components. So we've got these T-slot nuts, these square-headed bolts. We've got, I think that's it for these angle brackets and these maker frame beams, which are extremely small. They're very cute. Compared to 2020 extrusions, these are literally 1010 extrusions. They are twice as small as the usual 2020 extrusions. So yeah, these are amazingly cute. Compared to 2020 extrusions, for anyone watching, I think I might be able to snag something here. Scratch that. I'm not really willing to do that, but they're twice as small. So the overall machine is going to be very small and very cute. Most of the screws in this project are M3, so I'm just going to get out my M3 stuff. Well, that's unfortunate. Would have liked it if I had a 5.5 socket here, because I think that's the size of the M3 nuts, but I don't have a 5.5 socket, so I'm just going to have to hope everything goes smoothly with that. Worst case scenario, I can always try and figure something out using pliers or something. And the most important part is to get the 2.5 bit to be able to derive those M3 nuts and bolts of every kind. All right, here we go. So first, let's unpack these things. These Mecha Beam parts are, strangely enough, fairly free from any infringement whatsoever from our friends overseas, which is surprising considering that they, kind of tend to make um, everything, they make their own version of everything nowadays, and this is not difficult to copy. This is a 2020 extrusion that is twice as small with a tapped hole at each end. This is probably, and I guess, what is this, like anodized with black, and you could have it raw, it would probably serve the same purpose. It's really strange that, Make Beam is still the only people making these things, whereas there's probably some market for it, probably not as large as some other things, but some market. All right, so we need two of the large ones. The rest is going to be used later. Two of the small ones, and oh my, all as pretty as each other, but that's probably fine. One right angle bracket, which we have plenty of. All the quantities are fine. Most pieces we have a lot more quantity than is required, and yeah, so it was a bit of a chore to try and get everything nice and to the at the proper quantity necessary. And one nut. Are you serious? One ISO M3x4 A2 nuts. So that's a self-knocking nut. $380 A2. That's not a nut, guys. That's a bolt. Come on. It's one of these guys, I think. Is that it? Okay, no. Okay. It is a bolt, but it's not the square ones. It's it's these guys. Come on. First step, first part getting attached. Amazing. Serious? I guess they are a different standard. They're not the DIN variety, so they might have a different require a different bit. Yeah, they do. So they're M3, but they require a 2mm bit for some reason because they're a different standard. I mean, that explains it. Still strange to me, somewhat. All right. Finger tight. Next. Honestly, I don't know how much work that is, but I would have really appreciated if the team could have. I don't know if they did actually. Maybe I should check if the team could take these videos and sort of take a few screen captures upload them to wherever the repository is. I think it's the source tree repository or Bitbucket. I don't know. That somewhere like that where check the pictures and read it and not have to go through the videos. Although I can't imagine that this gives a few more views still. That's probably not the way to go. Do like the music though, it's very soothing. Excuse me? 2 T-nuts on top. 2 T-nuts on top, and they go in this way. The Festival of the T-nut. Excuse me? Okay, so this way. I'm looking at my T-nut bag and there's not a lot of them. Think that the quantity is right? I really hope it is. Because that would be embarrassing. Okay. Right angle bracket again. Should maybe get these things out of the way first of all. Da, 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 da. So stuff here. Many of these guys because I just realized, yeah, there's 25 pieces of Make Beam T-nuts and then there's 25 pieces of these ISO screws. So yeah. I probably didn't need a second bag of ISO screws or bolts for that matter. I don't know. Some people call them bolts, some people call them machine screws, some people call them screws. Everything is very, very confusing. Hold on, partner. Ask you to wait. Maybe I should get some music over this stream. Else it would get pretty boring. I get to listen to some music, but you guys don't. Anyone watching, that is. 4 square-headed bolts. Oh my god, there's so many of them in this pack. How many is that? 250 pieces. Holy hell. We are not going to lack in freaking square-headed bolts. That's for sure. Bolts down this slide. So one interesting thing about the sourcing, there's going to be several comments about interesting things about the sourcing I'm going to make in this recording. One is I actually sourced everything for the base and design, and everything for the updated PCB design and the laser attachment. I actually think that I'm going to have doubles for the PCB, because I think there are some parts that are used in the base PCB attachment that are not used in the updated PCB attachment, that are essentially replaced, and I got them both. So we'll see what happens then. Another right angle bracket, another bolt. It's going to happen. I'm so good. Speed running. It's what you call speed running. Two square-headed bolts. I'm not speed running anymore. I stopped the video. Um, predictable. Yeah, I think this build is very interesting. Not because of, you know, oh wow, we're using tiny parts. I mean, that is fun to an extent. Um, right now we're using mostly the Maker Beam stuff, but there are so many other parts and going in this. That's kind of crazy. I've used CNC mills before. I've been have certification for CNC lathe, but I never actually like looked at the specifics of tooling, power, or whatever. I've obviously learned that in engineering school, but application wise, it's interesting. Oh my god, are you serious? Here we go. Here we go. All right, that's that. Probably same-ish on the other side. Okay, this is where it's gonna be annoying, because I don't have something to actually screw these guys on properly. Hmm. Actually, that's not completely true. I might have something. It's really a pain that they didn't go the extra steps with this kit of putting in the 5.5 socket. Would have been great. Yeah. It's, it's not working. It's not gonna work. It's not large enough. Ugh. See, it's not fine either. So, I've got a few options, and I'm going to go and get something that might solve my problem. Actually, a metric socket, because here in Canada it's pretty difficult to get like specifically metric stuff, but it's probably going to do the job almost as well. Um, it's actually This is a 732, which I think is actually really, really close to 5.5 millimeters. Hopefully, I mean, it worked, so it must be. So let's do 7 divided 32 times 25.4, and that comes out to 5.55 or 5.56. So yeah, it is very good. It's going to work for our purposes. However, this is not pretty very convenient to use with hands, so I'm going to go and get a driver for this. I'll be back. I have the driver. This will most likely work beautifully. Yeah. But it might work even better if we have something that is exact, because this kit actually does come with beautiful, beautiful metric options. 5.5. Isn't that mighty convenient? It is. Okay. And this even ratchets. How useful. Okay. It's not going anywhere. So, we've got our socket, and we can keep going. Oh. Okay, do it for both sides. That's fairly simple to understand. Uh, key part of the build. There we go. Okay, well, I didn't need the two extras, but we're most likely going to need these square-headed bolts anyways. Eventually, the annoying part of this is by far going to be um, calibrate the device and make sure everything works, because this is not a product. This is an open source project that no one has even dared monetizing yet, for reasons I can somewhat understand. There isn't much market demand for something like this. Most people will simply, excuse me, is this working properly? So most people would simply go to a PCB manufacturing company ask them to make PCBs, the PCBs they want, and just be done with it that way. They don't have to take care of equipment. They don't have to calibrate equipment. They don't have to own equipment, and it's all the better for that. And it's true that that is a very convenient way of getting whatever custom PCB you want. The difficult aspect being the designing part. However, I am not an electrical engineer. I am not a mechanical engineer, actually. I am a mechanical engineering student. Shouldn't really call myself a mechanical engineer for now. Most probably soon to be CEP under the Ordre des Ingénieurs du Québec, most probably. And I personally am less interested in the PCB aspect, although it is very convenient to not have to use these pesky Arduino boards and go with the deal with the microcontroller directly instead of bobbing around huge development boards and prototypes or even finished products. Jesus, can you imagine that? But I am very interested in the manufacturing aspect of this whole ordeal, which is why I'm making a machine to make the boards, as this is my priority over the board itself. We have our first use of printed parts. That is not correct. Let's see. Apparently the link isn't working. Look here. And we called it the end. Oh my. That is not great. What? It isn't working at all. That's insane. Done. That's actually a problem. Um. Hmm. That's the link situation sorted. Uh. And there you go. So there you go. That's actually a problem. The key options, I think, is being very annoying. Filter. key. And there you go. This filter key is off. I think that's going to solve. Yeah, okay, that solved the problem. We're good to go. Filter keys are literally the worst thing invented by Microsoft, and here we go. Let's keep going. Where are my parts that look like these? Okay, these are the ones. There they are. One, two, and then these parts here. I think I've partly assembled. No. Okay, that's all the problem. We're good to go. Filter keys are literally the worst thing invented by Microsoft, and here we go. Let's keep going. So we're back. Business. And okay, so we have our 3D printed parts here. And two, so this frame is going like this. And then M3 by 20 hex bolts. So we have to go into the overseas hardware components and trying to find exactly what we're looking for. M3 by 20. That's 15. Oh, 16. Oh my. I should have relabeled them maybe because this labeling is not great. It's barely holding up. 3 by 6, 3 by 12, 3 by 8, 3 by 30, 3 by 50, 3 by 20. Okay, these are the ones. All oily and stuff, not great feeling, but probably very good for the part itself. Let's keep going. So these parts are supposed to mesh together like this. Which side is going here though? We have a nut side. Okay, not the nut side, the other side. So nut side goes there, and this side goes in here. Okay, good. Same with the other. Many 3x30s did we need? Because they have a lot there. And okay, only two. Obviously, it's a different standard. We have to change the bit. That music is nice. That fit though is not as nice. Oh my god, is it going to be like this for every single part? Oh, guys! The hole you want for M3s isn't 3 millimeters. You want 3.5 millimeters. Come on. What happens? People are mad. Okay. Oh god. You do the other side in a very similar fashion. Get some movement here. Oh, okay. No, 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 no. Okay. Okay. Gang. No. This is why you make them 3.5 millimeters instead of just 3 millimeters, because when you go and reach with your little tiny Allen key, which is included with the Maker Beam stuff, it's very annoying because then you need a lot of turns to make it through properly. Although I would say doing this does ensure a very good fit. So there's that. Okay, so now let's screw these things in properly. The holes are pretty nice. It's just I guess either I didn't put enough of a high precision on my machine when printing, or they're overestimating my machine, or uh, consumer grade printers for that matter. All right, let's bust out the M3 Allen wrench. Here we go. I actually don't have a lot. This is this M3? This is not M3. This is for their DIN stuff. That's gonna be a problem. No, that's not gonna be a problem. Actually, it's not. It shouldn't. Because I have this guy. Okay, it's still gonna be a problem. Oh Lord. I don't think I do have M3 Allen wrenches because M3 Allen wrenches are very useful in many, many, many situations. And darn. Oh man, I really hope this would be good enough, but it isn't. So instead, what we're going to do is we're going to undo a few nuts, which is fine. And we're going to screw these things using a simpler approach, which is just, doing everything at a time. Sometimes, you have an idea of how an assembly is supposed to go in your head, and you tell yourself, yeah, this can work. And most of the time, yeah, sure, it will definitely work. And sometimes it just will not work as you want. There you go. So now I can assemble this thing properly here after pushing this nut into place. There's two of them. Oh no. Every single time I need to fit M3 bolts into anything, I always use 3.5 millimeters instead of just 3 or any other measurement for that matter, which I think is correct, but maybe not all the time. I may actually have to go and get a or find a M3 or as close as possible to M3 Allen wrench, because this method may not be viable all the time. I'll do this for now. Okay, do the same thing on the other one. Blah 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 blah. Easy, easy. Okay. So two more of these bolts. Greasy bolts. And we can have this screwed in properly. stuff. There's an excellent connection, which is amazing. There is massive latency in the streaming, but you know, um, it's there. This you can ask for. Okay. Okay. With that, a bit. There you go. Yeah. Another advantage of getting the machine itself is that maybe you can actually make these things for other people. It's a big maybe because um, yeah, I'm gonna need to get an Allen wrench. That's just not gonna be very viable in the long run. Um, Especially because I think these are going to have to be left relatively loose because these I think hold the bed, and that is not is like the very final step, and I'm not going to like everything just to get that one thing working properly. And yeah. Mm, understand why the assembly is as it is, why Allen wrenches exist in the first place. But I am still very disappointed that my here is not working properly. To me, that is huge. Yeah, that's pretty annoying because it means I have to try and find a M3 Allen wrench, which is something that I know I have, but I don't know where it is. I really thought this Allen wrench would work. It's the wrong size. It's 2 millimeters instead of 2.5. Just a different standard. Also, this bolt here, having a lot of trouble inserting properly. There you go. Okay. You're filling with small parts, slightly smaller fingers. Put everything back together. Get an Allen wrench. Hopefully we can find something that fits somewhat, even if it doesn't fit as nicely. Um, um, a kid the other day that had like a few M3 nuts and bolts, which are always useful, especially here where just getting these types of fasteners is not easy because everything is imperial for some reason. And yeah, well, I mean, I could like print a tool that would do the job. I just don't feel like it. Wait a second. There's like a hole on the side of the driver here, and honestly, if you could slot something in there to just use it as a wrench like this, it would be amazing, but you can't. And I have no idea why they didn't make it so you could. To me, that's very dumb. Oh well. case, I was prepared for this. Not, you know, the worst thing, but okay. So I think this. No, this is a bit too big, isn't it? No, this one works fine. All right, we found an M3 wrench. The day is saved. These are metric wrenches too, I think. Yeah, metric hex wrench. It's not just metrics because every hex wrench I get ends up here, but there are metric wrenches in there. Great, so we've got our M3 wrench. The day is saved. We can keep going. All right. So now we're getting more of these guys. Let's put this aside for now. I should actually work close to the camera, I think. It would be nice. Be easier to see what I'm doing. Let's rearrange things here slightly. So I don't need this for now. Okay, sure. If I place this here, I think that's a better shot. Happening. And this equipment over here temporarily. This is becoming a bit of a mess, but it might be worth it in the end. Okay, we'll just go with this. Oh. Too small, make your beam profiles. 4 right angle brackets. Um, 8 square-headed bolts. Are we just building this the other way around now? I guess we are. Not going through this thing too hard. Because... be exact. Now we have to do it 3 more times. Quote unquote follow along. We're right now. The video I'm using to build this, which is, as far as I know, the only instruction set provided by the end team. On the first assembly video called Frame Assembly, 6 minutes, 16 seconds. Actually, maybe I should add it to the stream. That could be nice. Probably not going to finish everything today, and so I will have a break eventually. Think we still have 2 hours to go. And then I'll see for tomorrow have something a bit different so that we have the video playing along as I go. It's not the greatest, it's not the easiest thing to set up because right now I'm using, actually, I don't own a single recording camera. Considering that there are currently 2 things recording me. One is the webcam over here, and the other one is a camera of a VR headset, which is over there. Ceiling, and it's very convenient because it can just get a nice wide angle shot of the table, even though it's very low resolution. It still gives an idea of what's going on. Guys, there is right now a lot of black in the live stream because this camera is lowish resolution, 720p, which means that, I mean, compared to my usual screen, OBS likes from my computer to record 2K. That is tiny. So obviously, I'm not doing any like sort of game capture or anything, or window capture for that matter. And so that's what I get for now. But now I've assembled my two parts here, and we'll see what's the next step. Left motor holder printed part. Left motor holder printed part. Motor holder printed part. Is that it? I think that's it. And one square-headed bolt. Uh, Here on the computer that's actually live streaming right now, and just look at it from time to time. I don't think it makes a huge difference in the whole scheme of things. So we have that, and what did they want us to do with this? Just insert it somewhere. I have those here. Here we go. Just drop it. Drop it where? Do that. Oh, apparently I can't. Jesus. I'll just do it in my hands. I don't know why it's so complicated. Complicated. Oh, goddamn easily. All right. So let's try to open this up a tiny bit. We'll drop in easier. Taylor are as good as theirs. Oh boy. Okay, here we go. Uh, Better. We'll make it work. Just plop it in there, brother. All right, one of the larger aluminum profiles, 2 square-headed bolts. Oh, you put these 2 things through that one to these 2 holes. Oh my. My holes are just not quite right. Uh-oh. Issue here. Okay. I have a ring which wants to. Hey, we have a soldering iron. For this type of repair. Oh, decent temperature. That's done. What's the closest thing to 3 millimeters? Amazing. We'll just use that then. Holes with this drill bit, and that will solve the problem. I think I have a hand drill. Use my hands, my actual hands, do this. Should make a hand drill. Drill, and we can now drop this guy in with ease. Here you go. And put these two square-headed bolts. All right, here we go. So put one bolt here, double bolt there. Now we raise this guy slightly, and this is finicky. Everything is nice and slotted. There we go. Okay. Whew! That was the wrong side for a second. Three self-locking nuts, 3 M3 washers. Okay. M3 washers. Those. And then self-locking nuts. We've got a few here. 1, 2, and 3. Oh, is that going to work? Because my socket is large. Yeah, my socket won't fit. Their socket fits, but mine doesn't. So that's a shame. I think they do protrude slightly though. That might help. design. Your tool might work, but how does your socket fit something like that? That's a super small socket. Holy. Oh, la 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 la. Not great. It's just an M3 socket. Print something this small though. This is very, very small. If I had the right socket on my little kit there, I would actually be able to do something pretty good too, but as it stands, I don't think, yeah, my best efforts are because this. Shh. Tightness out of this. Just using a natural socket, but probably sufficient. There are 3 of them after all. I'll just go with this. 1 M3 washer. No. Oh yeah, okay. 1 M3 washer, 1 extra M3 washer. 1 make beam T-slot nut, 1 M3x6 hex bolts. Okay. Three by 6. This is where I have all of these again. 3 by 8, 3 by 10, 3 by 16, 12, 20, and 3 by 6. We go. Doing? My god, there's so much securement. Is that all really necessary? Guess it might be. Must be. And now we have to do both sides. All right, that's great. Here we go. Three lock nuts plus 1 bolt. This is never coming up. This part is going to break before anything comes off. For anything even moves an inch. Although, you know, when you think about it, it is like good design that they've done something like this because it is very crucial that these things do not move. Especially over time. It should never loosen at all. Now I'm just going to use my power drill. To loosen up these holes. I'm using white parts, by the way, because I have a ton of white plastic. The advantage with white plastic is that if you wish, you can recolor it whatever with minimal effort. This specific application, it sort of contrasts well with the black anodized Make Beam profiles. Okay, I did do that one. Right. Let's get more T-slots. Bolts. We need 3. More washers. We need 4. Especially the washers on this, like 4 washers to attach one thing. That is impressive. 1 T-slot nut. We're not gonna need the Allen key anymore because we've made the holes nice and loose. The lock nuts, 3 of those. That's the same way you did the other. So instead, finicky way, one at a time. Them in one at a time like this. You have to turn them properly. What? Oh. Slid in properly. You can just use the washers and the nuts to secure everything in place. Nice and super mega tight. Ever, even after hours upon hours of use, hopefully. Okay. There's no washer there. Washer. Go. Socket of there is the tiniest thing ever. Jesus. Hurt myself there. The long nose fighting back. Loud. Oh, where you're assembling, kids? Not doing that properly will lead to you abusing your long noses even more. What a waste of time. We gotta insert these things again. Go in. Oh my. On. It keeps turning. Control it pretty well. I use the Allen wrench like this. Haha! Now we're on the correct orientation. Pushes in. And seal the deal. Uh-oh. One fell out. For further use later in this project. Just does not. And last, are at the correct orientation. Oh my. Oh. Making sure everything is. And here we go. We finally got this assembled. Making progress. Timing belt tensioner spring. Oh my. We're going to have to dig for that one. Okay, let's dig then. There they go. There they are. 2 timing belt tensioner springs. 2 left bed holder printed part. Left bed holder printed part. That's 1. That's 2. 2 right bed holder printed parts. Wait, what? What do you mean? I hope we'll tap on one of the one of the parts. I've got this, and I think I have another one like it. There you go. Three by 16 hex. 3 by 12. 3 by 16. I think. Yeah, these parts. Okay. Spring is like this. Pull them both through, bolt through here. What? That's the wrong one. There you go. That's the right. So just take the drill. This. Was specifically made for me to thread it into. Come on. Doesn't actually hold it properly. So you're meant to thread in those things, which is annoying because now I can't thread through them. And I was not supposed to drill it. But the really annoying the springs don't seem to match. No, they do. They do match that. Okay, so but there's only one side. I don't have springs on two sides. They're the same. It's crazy. I bought them from the same bin. Okay. Actually, I think I do have something for that. So it's going to thread this guy because now it's way too loose. I've collapsed the hole. Not something I particularly want to do. On the other hand, sort of thread. So I mean, I could use this guy here. Is that? Yes, I'll have to reprint another one of which, considering the size of the part, really shouldn't take all that long. Spring, okay. And then this spring is smaller than this the other spring, but I think I have something for this. So we are saved because it's an M2.5 spring. This is an M3 spring, but I happen to have M2.5 by 16s, which is a rare type of screw. And this will work. So all I need to do is reprint one of these guys. Actually, not one of these guys. You need to reprint exactly it drilled through. which is going to be interesting because in the Bitbucket files, everything is sort of placed together. So the right thing. Yep. Yeah, whatever. Here we go. Here we have the I'll pull up the Ant PCB stuff. And we have the oops, I'm hiding the camera right now. We have the motor holder, PCB lock, limit Y support, pulley support. I think it's pulley support. That's not pulley support. So I'll just have to take this file and reprint what I need, which is going to take minutes. Open the bed holder part. And now I take these guys, save as spring parts STL. Them as high as possible. Might want to use these parts actually instead of the ones I have right now. They might be higher quality. Eh, not really. A lot. Few supports. Yes. Here. Sweet. The result. Oh. The print and everything should be fine. 32 minutes. No time at all. This is more than fine. Here we go. Well, that's going. We can go back to our regularly scheduled event. Like this. Using that one part, which I sort of screwed up. So now we're going to use the other side. Going to work. Thank you. So well, now we have one budget holder. So there you go. And then two of these square bolts. Not nuts. Oh no, these are nuts actually. Oh my. Oh. What? How? Wrong one. No. Side, that's what's happening. What fell? It's one of the bolts. Oh, there you go. Okay. Ish. If you're on the mirror, this. I see what's going on. Is that way. Hanging out. So I was correct the first time around. Good to know. Okay, so now this I know for sure gets drilled. Because we are going to put a M3 bolt through. Screw it into a nut. So all right. That'll make it a bit easier to assemble. So now we know we've done it correctly. Push everything in. Is a 16. I'm using the wrong one. This is the one I should be using. Both need to be drilled anyways. Nice. Nice and easy. Screw this in. Screw this in. Uh, not being very friendly. Okay, this might be good. Get the part in half an hour. The meantime, we can, I think, um, somewhat So just pair these guys together. So this one is a 16. This 16 bag and put it back there. Get 2 more 20s while we're at it. Here we go. Those are 12. Those are not 16. Oh god. There you go. That's the larger one. There you go. That's 16. Alright, so back to oops. It's one screw recovered. One. And we'll put this one here temporarily. Okay. Those 2 parts. Oh god. What's next? By the way, at 10 minutes now of a 24-minute video. No why. Panel. This is on that side. Okay. The ISO bolts, which I have not used in a while, so they're not like here. There they are. I think those are right. Yeah. Going to need the other bit. Need 4 of them. Well, so that's that. Whoa. Snapped fingers and obtained results. Also, that's 2 T-nuts unaccounted for. Oh my. This. Let's deal with these bolts. We're good. Let's screw this in nice and proper. No, we're not good. Just have to screw the top in. We have to replace this guy. The nuts placed at the end of these square-headed bolts act as little knobs so that I can turn them easily, which makes this all the more easier. Now we get to place this part here. Right. And proper. Actually, let me wait a bit before saying that. That's shaking. Let's just make sure everything is nice and screwed in properly. Assembly. Yes, yes. All right. So if there's anyone joining in right now, I'm making a PCB mill, which is like a tiny CNC mill that's specifically made to carve out PCBs. And this is not an original design. This is an open source project made by the Ant team. And so this this CNC is called the Ant PCB maker. And so after assembling all the components and having all the tools at our disposition, we can now start building the thing. And we're beginning with the frame. I'm following instructions given by a video, and this video is put on the Ant PCB Maker official channel, and it's called Frame Assembly. All right. So these large aluminum profiles. We need 2 linear rails, some of the most expensive components in this project. And how many ever be longer than the profiles? Well, we shall see then. May require some light sanding, which hopefully I will not have to do. This has been kept well in their packages. Very, very good. They are not longer, so that's great. Oops, that's not great. Hopefully the balls don't fall out of the carriage that easily. So fuck. Okay. It's not very good. That is indeed very, very bad. black. Okay, so this side seems full. However, I heard a ball fall on the ground. That is not very good. It's actually a very bad sign. There's one ball on the ground at the moment. For it. Try to find it. Oh, I think we might be missing more. Not a great sign. That stray ball that fell. Slides in. This is going to slide in easily when actually do it. Stray ball. unable to find the ball. Looking in the space, we might be one ball short, which would account for that ball which fell. Places where it could have fallen, that it's would be quite difficult to find right now. What can be done is to reinsert this. Very easy. Okay, let's try it again. If balls only fell from one side, if I insert, be fine. It will be fine. Really would like if I could find that ball. This is going to be a bit of a dead moment. I am going to make an extra effort to try and find it. This is great news. I have found the missing ball. And now we can know for sure that the rails are even and nice. Now let's try and reinsert this rail gently, straight. Oh, and we're perfect again. So that was a bit of a bit of an adventure, but now We're back on track. Still there? That's fine. Rails until they are the right length, just the right length, which is great. We require 10 T-slot nuts, 5 for each rail. Okay, we might actually be out of them after this. No, we will have one left. I have no idea why we have one left at this point. Actually, no, I do, because they come in pack of 25. You have 2 left. Actually. They don't... They come in pack of 25s? Anyways. 5 each, and we've got 2 T-slot nuts left. And is that it? We must use bolts for this, right? Okay. M3x6 X bolts. Oh, we're good. Yes, then our parts are ready to go. That's great. So let's ready the 3x6 bolts. We can put this back. Thank you. 3x6 bolts. We need 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be 10 holes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we need to space 1 for every 2. So 1, 1. No. Okay. That's fine, actually. So we're good on this one. So the annoying part is that it's actually a tad bit smaller than the extrusion. I'm going to use my calipers to try and understand what kind of space we're talking about. 1.06. Okay, let's screw it in nice and proper. Move. And then we measure. Then 1.14. We aim to have 1.04 on each side. That's not right. Zero 0.8 on each side, actually. So, you're wrong. All right. Side. A lot of slack on this. Slack. Boy. Oh. Perfectly is. Probably be enough. I think we don't have a choice. And it's going to be like not exact. Although I don't like it. Love it if it was like a sort of a it's not moving. This guy is still screwed in. I can measure it all I want. 1 millimeter, by the way, that's too much. As this is similar, I don't have a huge problem with it. So this side, this side, this side, this side, this. What? Not properly. I'm still sort of stressed out as long as there's no end caps on these rails because I could still have problems with the carriages derailing and me having to find balls on the ground once again. Although it really wasn't that big of a fix once I did find the thing. The funny part is, although these are great bearings, they make terrible rollers. Well, by that I mean they make terrible, like, rolling marbles. It's a strange bias. I don't know what's giving it that. Balls there. Why can I not move this? Okay. Much tighter. Wow. It is still shorter. Yeah. Definitely still shorter. But lighter. Should make them equal. Try and make this side more flush here. Like this. Very hard. Anymore. And it still moves. No, this one still moves. My god, this thing must be screwed in tight. There is no friction on this guy. I mean, understandable. The rail is supposed to be like low friction. I've achieved a good I've achieved something good with that one. This one I'm still a bit annoyed at. It's significantly shorter. Okay, so I'll see if I can show this. So this one, look at this end. Fairly flush, but it's not really flush. This is flush. Pretty freaking flush. You see that it's still the linear rail is still shorter than the extrusion, which is what we want. Here, this is pretty flush, but this end, this is uneven, so it's significantly shorter. And I'm trying to make the gap the same on both sides, but because you have to screw this thing down with so much force, it can be difficult to do that kind of adjustment. It just moves that way. So maybe if I move it a bit further, I can trick it. To have it even. Even. end up exactly as it was before. Getting any better. Just going to accept final result as it is. Okay. It's most likely good enough. We'll kick in way before we hit the end of that rail. So now we've made sure that it's smaller than the extrusion. Can actually harvest the parts here. It should be cold enough now so that we can just pop them easily. Hopefully that's the one we need. Is it? God damn it. This one's right. Those are significantly better. I may replace that. Fuck. This is what happens when you don't have proper support. It's not going to focus because it's a dumb camera that can't focus. Maybe it will. A bit strange. And this one, it's much sharper. Maybe I'll replace the one I have right now with this because it's a better version altogether. Okay. With that bit of support. Ports. Have to get removed. Place a screw here. Now we have a nice open hole. And hopefully, we can screw this spring in with ease. It will screw in. Perfect. Even with a 2.5 2.5 millimeter. Nicely. Good. Good enough. And now, M3 Allen wrench, which I went and got previously to screw this in the proper way. Just going to remove some flash between the bed and the part. All right. I get drilled. Not just might, definitely does want to get drilled. Insert the bolt. On the mark. Amazing. Okay. So now we have these two springs, one with an M2.5, the other one with the M3. And sure, we'll use that part. We don't really need this extra part. We'll keep it for now. Now that's fully assembled. And we've got our rails pretty tight. Give them a bit of a twist with the M3 Allen wrench to make sure everything is really tight. Again, this rail is made to be very low friction. So the surface finish is amazing. And there is some lubricant that was applied on around the rail. This, however, makes it a lot harder to get a nice and well, not snug, but like it's very difficult to slide on things. It requires a lot of pressure to actually stay on a surface. So now these are pretty good to go. So what's the next step? I see why we need to do this. Insert 2 bolts. Ah, damn it. I start everything over again. Yes, without screwing it up. It's too tight. Okay, I'll take care of that. I'll take care of not screwing the self-locking nuts too tight. Okay. The exterior like this. This slippery rail is so difficult to assemble. Right. Next. For the other side. Beautiful. All right, so first things first. Flicking nuts. Oh, right. We will solve this problem. Do many other things. Here we go. Headed bolt and 4 luck nuts. Okay. Not very difficult. I think I have an idea of what's going to happen in this step. All right, so I feel like we don't have many steps left in this part. We still have a few minutes to go. But once the frame is done, that'll probably be it for today. And the rest will be done at a later date. I mean, most likely tomorrow. Rest, probably the second step. Because this really did take a while. There was the mistake in breaking the part for the bed holder. That didn't wasn't really it so bad because it's a 3D printed part. 3D printed parts are easy to make. What was a bit more concerning was the dismounting of the carriage of one of the linear rails and the falling on the ground of one of the bearing balls. So that wasn't so great. Let's prepare the remaining of the parts here. This will be split in a few days. There's a high likelihood that any part that was not yet obtained will arrive by the end of the build, which is convenient. have more of these encased nuts, which have to be turned with the pliers. Not the best solution to this, but it's a solution. I just want to make sure this is. Understand that we must not screw these guys too tight, but let's make sure this is properly seated, yeah? Let's try to not have that happen again. Let's I'll do the same thing on this side. So one screw slightly, make sure it's properly seated. Screw, but screw not too tight. And screw this guy on top. As tight as he's gonna go. Probably good enough. And where? Okay, on this side underneath. Let him go. Got it. 10 square-headed bolts. Oh my. Why 10? Oh, there's 2 on top. That's why. Locking nuts. Okay, I get the idea. Let's get this. So, hmm. Except this time, there's not nearly as much stuff to worry about. There. You go. Side. Uh-oh. Not ideal. All right. Bottom part. 2 bolts over here. That's a nut. There we go. Bolts. And seating. Okay, everything is nice and seated. I'll go get that bolt. Screw everything. I just want to verify one thing. So this is a MDF plate, like they recommend for waste material, but it's half an inch in thickness because there isn't such a thing as 10 centimeter plates in good old Canada. So yeah, okay. It looks like this is not going to fit nicely because it's too high. It's a half an inch. It's not a 1 inch. It's a half an inch, which is slightly larger than 1 centimeter. It's something that can be overcome. Is there a small modification to these parts right here? Yeah, it would require a small modification to these parts, which is probably something I can do posteriori, so sort of after the fact. Yeah. Okay. Parts too, so they'd be easy to modify slightly, and they're easy to insert. They don't really do much, so that's great. I'll get on that as soon as I'm done assembling this frame, which I will finish now. think I messed up. Whoops. That's fine. As anyways. Let's get everything somewhat sturdy-ish, and we'll switch around these bed parts. Now there's no risk of these guys derailing, and the length difference didn't really super matter in the end. Can both get their full range. So that's nice. Now, yeah, these are open, these are closed, which makes sense. So this one is wrong. Is wrong. So we'll just unscrew them. Here and here. Uh, through both. This one is going to require a bit of help. Right. Let's get it nice and drilled. There we go. Okay. Now this guy. I think that this. Saying that this is large enough. This will not fit under these guys. What? It's supposed to go out both sides. There's no way. Later. I'll just con that. Okay. Missed the nut here. Fortunate. Here we go. I got it. Okay. Next. A lot of stuff still to do. Okay, the left pulley parts. There's one there. Let's put them here. More pulley parts. More pulley parts. Should be around here somewhere. There you go. Here we go. Self-flecking nuts. Oh no, we have to do the thing again. Fine. Hopefully we don't have to do too many of those. Okay. pulley 16 teeth M3. Ones. M3. The locking washers. Where are those? Eight. One, three, 4, 5, 6, 7, 8. Okay. 4 and 3 hex nuts. So just normal hex nuts. I'll get some of that. And 3 by 30 hex bolts. 3 by 30. There we go. 4. 8. And 3 by 8. And 3 by 8. That's required, and I have 25 pieces, which is all right. Literally just go in, like. Dumb help, but like. Drill these holes first. Come on. It's a much easier way of doing this. That. Every single hole here is supposed to be. Yes. Okay. Every single hole here has its three. So we're gonna drill everything. This is going to make it very easy. These hex nuts back in. This hole might have. I did. I did forget to drill that hole. There you go. There you go. Push that guy in. Same here. We're gonna do the same thing for the large ones. Use slightly larger bolts for that, since poor M8 bolts won't be able to reach. Could use the big ol' M30 we have at our disposition, or use a smaller bolt that also does the job. Like a 20. Design. I tend to use it a lot myself. It's very nice. Oh. Alright, so now we apparently will use these guys here that we've placed on top to do this. She's gone. Tried and true player method that they have is really, really small. A 5.5 millimeter socket here. Just about right too. Socket can like sort of get it, but it can't really tighten them much. Oh no. Tightens them somewhat. This is gonna probably be good enough. This is going to need to be drilled as well. All right. Whoa. Okay. Use locking washers on the pulley's bearings. All right. Seems like proper use. That's it. So the second we're done with this, we're done with the frame assembly. Okay. Guess I shouldn't tighten it so much then. That's fair. Tight. Feels like they rotate nicely and freely. Okay. Well, that's the end of the frame assembly. So what we've got right now is like like this. So we've got some of the movement components. We've got the waste material bed holders. You've got the motor holders here, the motor brackets, I guess you could call them, and then some of the pulleys are already on there. So we're doing well. There were a few mistakes. There was the dropping off of the carriage, which led to having to find one of the bearing balls on the floor. Took some time. There was mismounting of these motor brackets once. There was almost mismounting of some other components. There was the fact that I didn't realize that these guys versus these guys were different. So these ones block the waste material bed from going any further, whereas these guys here really don't have anything like that. Also, I'm now realizing that this probably like these springs probably are there to retain the bed, so the waste material bed, meaning that I may have to modify both these and these parts if I'm going to use a slightly thicker bed at half an inch. And I think that's about it. And we'll end the stream for today.